To understand how something as intangible as thin air protects us, you need to find a meteorite that has survived its fall to Earth. Meteorites are rare, so you need to go to great lengths to track one down. Dr. Phil Bland is a planetary scientist on just such a mission, leading an expedition out onto the barren Nullarbor Plain in Western Australia, 3 days' drive from the nearest town. The Nullarbor is vast, about the size of Great Britain, but it's as flat as a pancake, so it's the ideal hunting ground for meteorites. Nothing has changed here for millions of years, allowing meteorites to accumulate undisturbed. The team head off to scour the desert like a police search team.
The Nullabor's a good place to look for meteorites because it's a limestone plateau, so dark meteorites stand out pretty well against the limestone, and there's not much vegetation, so you can see the ground quite clearly. Meteorites are quite dark, and when they've been out here for a while, they rust a little bit. They have chunks of metal in them, so you get a kind of a dark, rusty texture.
After 3 hours of searching in temperatures above 45 degrees, the team haven't had much luck.
I think I got one. Looks pretty good.
That's lovely. Oh, that's a good one.
Looks like it's got some nice fusion crust.
Yeah, that's lovely. The glassy stuff that melts when it comes in.
Must have broken up in the atmosphere before it hit the Earth.
Yeah. You can tell this is a meteorite because it's quite heavy, it's quite dark, it's got little rusty patches, and it's got this smooth surface from when it came through the atmosphere.
This little chunk of rock would once have been something much more substantial.
Before it hit the top of the atmosphere, something like this might have been part of an object the size of a washing machine or a small car, but a car made of solid rock. And that's punched into the atmosphere, the surface has melted and been stripped off, and then remelted and stripped off, and gradually whittled down to small little chunks like this. An object like this will hit the top of the atmosphere at about just under 20 kilometres a second. Now the bulk of our atmosphere, almost all of it, is within 60 miles of the surface. So if that didn't slow down, it would transit the whole atmosphere in 3 seconds. But it does slow down. The atmosphere acts like a brake on it and strips material off, and gradually it'll slow down to the speed as if you just dropped it off a tall building.
Without Earth's atmosphere constantly protecting the planet from such projectiles, life on Earth would suffer a regular bombardment from objects in space.
What that tells us about the atmosphere is that it's an effective protection for us and other life on Earth.